So let's see what are the results and what we are going to expect from the model. So the estimation has run here. We can see the path coefficients. So here you can see the results like this. These are the results of path coefficient. You can see uh, what we need from here as per our model. We need to copy the results from here. We need to paste here the results like this. We need to delete the irrelevant table. We just need to see this column, and this one. So there are some certain errors that there are certain rows that we don't need to find out here. If we see our basic model, what was our basic model? If I would like to show you, just a minute. This was my basic model. Here I would like to see, first of all, DIC as a first hypothesis on bank performance, dynamic innovation capability on bank performance. That was my first hypothesis. So I need to see DIC on bank performance in this one. So I need to arrange this table, DIC on bank performance. So can I say that my first hypothesis is accepted? Yes. There is a positive impact of dynamic innovation capability, which is statistically significant. So what is the decision? What could be the decision over here? The decision is my hypothesis is accepted. This was my first hypothesis. Now, what is my second hypothesis? Innovative work behavior impact on bank performance. So I need to see here innovative work behavior on bank performance. It is also basically accepted the result. So this is also accepted. Then what is my third hypothesis? If I would like to see from here, my third hypothesis is basically the moderating impact of IWB between DIC and bank performance. So I need to see from here, this is basically the moderating impact. I can put it here, and yes, this is also significant. So it is also accepted. And we can say that it is increasing, innovative work behavior is increasing the dynamic innovation capability impact on bank performance. It means if innovative work behavior is basically adopted along with dynamic innovation capability, it will enhance the bank performance. So these are the results which are mainly required for the analysis. So this is how you can show your results in order to support your hypothesis, in order to support your analysis, and in order to support what is your conceptual diagram. So this is how you can construct your higher orders. So next, what we need to do is we need to consider the CBSEM model. So I need to save this one. I need to go back, and here is an option of CBSEM. You need to click over here. You need to write here the measurement model, save it, and it will show you blank screen, and you need to recreate your model. For example, for the point of simplicity, I will create my dependent variable like this, that is MP. You will see that with indicators you are showing the error term also. It is basically the covariance based method. It is CBSEM. In case of CBSEM, we are also considering the measurement model, the basic consideration for model fit indices. So we can consider here the same indicators but with error term addition. You can link it upside like this. You can make it some space over here like this. You can see zoom in, zoom out. The other variable was this one. You can put it here like this, and you can put in the bottom side like this. And you can construct, first of all I would like to show you the simple model construction using CBSEM. So this was my first independent variable. No, this was not. Basically this was my first independent variable or lower order constructs like this. I can put them upside. Then this was my second constructs like this. Now let's suppose I would like to run the model based on these. For example, let's suppose this is my dependent variable, and these are two my independent variables. So how can I run the measurement model? First of all, you need to understand, when you have more than one independent variable, you need to correlate them. There is an option of correlation over here. In case of CBSEM, you need to correlate your independent or your exogenous variable. So you need to correlate your independent or your exogenous variable. So first of all, I would like to correlate my independent variable, but always remember, in case of your measurement model, I was discussing about CPSEM, and I have discussed that you need to correlate your independent variable. But in case if you are running a measurement model, there is no independent or dependent variable. All variable are need to be correlated with each other. So you need to correlate this with this. You need to correlate all your variable just like this. So you can see here, you can also change the direction of these correlated variables, and then the correlation sign. Just a minute. There should be an option, but the option is not been appearing. All right. Yes, invert connection. You need to go to the select button, and then you select here invert connection. It will looks like this if you want to change this. So first step is you need to connect using the correlation button in order to have some correlation. That is why it is covariance based technique. So the next thing is you go to the co calculate button, and you will see only two options here: the basic CBSEM algorithm and CBSEM bootstrapping. You need to run the, I have shown you that you need to run the equation. You just go to the calculate, you click the basic CBSEM algorithm, and you will find the result like this. So it is indicating some correlation. And what you need to see here, you just need to click open report, and you need to see outer loading from here first. And you can see here the standardized matrix list. You need to click matrix standardize, and you will see the results like this. So these are the outer loading values which are greater than 0.70. Here are some values which are less than 0.70, but you can use them because they are close to 0.70. Then you need to see the constructs reliability and validity, and it is also close to 0.70, and they are good. You can also see the discriminant validity. You can see the Fornell-Lorker criteria. These values are less than from the first value, so they are good. You can see the HTMT ratio here. The HTMT ratio is also good because it is less than 0.90. Here you can see that there is no cross loading over here. So in case of CBSEM, you can only find the Fornell-Lorker criteria as well as HTMT. The interesting thing in case of uh, CBSEM is basically the model fit indices. The model fit indices, if you click over here, it is a very large table. You can find here the p-value. The estimated p-value is greater than 0.05. Here, basically, it is indicating that model is fit. The RMSC value is less than 0.08, and it is a good one. You can see the NFI value is greater than 0.90. So there are a lot of values you can find here. It is a detailed model fit table. A lot of researchers basically prefer the CBSEM method because it will provide you the model fit values which are better than the PLSM model fit values, because in case of PLSM, you will find only two values of model fit. So a lot of researcher does not recommend the PLSM due to their limited number of model fit values. So these are the model fit values of PLSM. But in case of CBSEM, you can see here there is a very large table, and all the values are indicating good fit. So you need to see the estimated model values. These are very good fit. So you can see here, you can also find here the R square values. Um but because we have run only uh, the measurement model, so it does not require the R square here. Because there is no indication of dependent variable over here. So this is how you can report the measurement model, the same tables. First, you need to see the outer loading from the matrix standardized, this table. Then you need to see your constructs validity and reliability, this table. Then you need to see discriminant validity, and from discriminant validity, you can find the Fornell-Lorker criteria and HTMT ratio. These two tables are enough for reporting the discriminant validity. Then you need to report the model fit from here. So these tables are good indicators of model fitness. Then after doing this, what you need to do next, you need to rerun the model. I have used the measurement model here. I need to run it again because I could not save it. This is my dependent variable, and this was my independent variable 1. like this, and this was my second independent variable like this. And let's suppose I want to run a bootstrap model on the basis of these two variables. So I just need to align them. I can decrease their size. And when you need to run the bootstrap procedure, you need to connect your independent variable as a correlation. This time you don't need to connect correlation with the dependent variable. So what you need to do is create a correlation between your independent variable just like this, and you need to connect your independent variable with your dependent variable, and you can see there is an error indication has been appeared over here. So this is basically how uh, a CBSEM respond when you create a model using a CBSEM. So this error sign basically indicates that this is the dependent variable, and these are independent variables which are correlated using the CBSEM technique. So you can run here the CBSEM bootstrapping, and you can use the complete slower procedure, bias corrected error procedure from here. And what is you don't need to change anything further. You just need to click start calculation, and it will estimate the model, and it will take some seconds just like PLSM, and it will estimate the model. So just wait. You can create the same set of variable, same procedure from here. The moderation analysis does not run in the same way as we do in RPLSM. Here, moderation analysis is quite different if you want to run the moderation analysis over here. So this is basically the structural model. You can see here it is run. Uh, you can find here the standardized path coefficient and p-values, and just like this. These are the path coefficient and p-values. In parenthesis, you can find uh, the p-values of your path coefficient. In outer model, you can take them as a blank. There is a r square which is 0.072. You can see here the path coefficient, the standardized path coefficient. You can see the MKTI is positively and weakly impacting the market performance. Then ORGI is positively and significantly impacting the market performance. You can create the mediation analysis over here, just like we have previously done in Smart PLS. For example, I want to create a mediation analysis on the basis of, for example, like IP1 to IP5. I would consider it as a mediator. This is mediator. For example, I would like to hide its indicator. I would like to hide its indicator to its indicator also. And I would like to create the mediation impact over here. I just need to connect my independent variable from here to here, then from here to here also. So you can also drag it here. This is a good one as a mediator. You can run CBSEM bootstrapping procedure over here just like this. You just need to wait for a couple of seconds. It will show you the mediation results. So after doing this, I will try the moderation analysis, and the procedure is quite different from the previous one, and you need to understand the procedure. Just wait for a couple of seconds and we will see the results. So the model has completed. You can see there is a significant mediation analysis, and you will find the path coefficient results over here. You can also find the standardized path coefficient results over here. There is an impact of IP on MP, that is positive and significant. Then MKTI on IP, that is insignificant. You need to see the specific indirect impact, and you can find when you are using IP as a mediator between ORGI and MP, it is statistically significant mediation impact between ORG and MPI. But in case of MKTI and MP, the mediation impact is not significant. So here we can conclude that in case of ORGI, the mediation impact is significant, but in case of MKTI, the mediation impact is not significant. So how the moderation impact basically considered over here? There is a procedure which is known as mean centering procedure, because you cannot find here any option for moderation impact over here. Neither we can find in case of calculation, nor we can also we can also not connect the IP as a moderator over here. For example, if we consider here the IP, like if I would consider here the IP, like, just a minute, why they are appearing. Yes, I would like to hide indicators, and hide indicators. I would like to connect them as a moderator, and you can see it is not connecting like we done in the PLSM. So how can we do the moderation impact in case of CBSM? So there is a procedure which is known as mean centering procedure. You need to mean center the IP term. And how can we do it? We need to open the Excel file of its data set. For example, I have its data set, like for example dataset 1. If I need to use this dataset 1, how to mean center the dataset? I would like to mean center the IP. So how can I do it? I need to insert a column over here. I need to create a variable name IP, and I need to average the indicators like IP1 to IP6, like this. I double click this option just like this. Then I go to the last row of the same row over here, and then I need to create again the average of the whole row. I need to select from the first cell to the last cell, just like this. click enter, and it will show you the average value. Now, what does the mean centering mean? I need to put again another column and IP center. So what I need to do is I need to subtract the mean center that I have calculated previously here from each value. Yes, this one, and just find out like this. Yes, this one. You need to put at least 5 to 6 digit after decimal. These are 4, 5, 6. This is fine. So this has become a mean centric value. So what I need to do, I need to load this data set over here. Delete source, import data. I think it was dataset 1. Yes, I have used this. Import. And you need to verify that you have created mean center value of it. IP. Yes, IP mean centeric. So this is the value I have created over here. So what I need to do, I go to my model. This was my model. I need to use my mean centeric over here. This is basically interaction term that we have created over here. I need to connect this with my dependent variable. So this interaction term has been connected. If you would like to see the moderation between independent variable and dependent variable, it will show you the interaction term. It will show through the interaction term. This is the procedure which is applied in CBSAM technique. So you need to go to the CBSAM bootstrapping and you need to run this procedure. You need to wait for a couple of seconds. Till then, if you have any question, you may ask in the chat box. If not, then you need to wait for a couple of seconds to see the results. Yes. So it has shown you a positive impact and it is statistically significant. You can see the standardized path coefficient. Here, this is interaction impact and it is significant. So it is showing a significant interaction impact, and it indicates that if you consider the IP as a moderator, it will increase the impact of MKTI and ORGI on MPs. Here you can see the total impact also showing the same. And there is no need to see the specific indirect effect, and it is also not showing over here. So this is how you can interpret your results. You can also create some second order model or higher order model over here. For example, we can consider, let's suppose we have MKTI, we have ORGI, and we have PRDI as a third indicator, like this. you need to hide the indicators just like this. You may include the other. You can find the fourth one like this, hide indicators. Now these are the lower order constructs of our main variable, which is basically the dynamic innovation capabilities. You need to put these indicators in the same way as we have done in some PLSM, just like this, and you need to hide these indicators, and you need to connect in a reflective mode, just like this. You can create correlation between them. Each one of them must have been correlated with each one, just like this. 3, 3, 3, and 3. Yes. You need to connect your dependent variable with this. For the case of simplicity, I just have created higher order constructs for our independent variable only, but you can create your variable, you can create for your dependent variable also, but for the point of simplicity, I have created this. I can include here my second dependent, which is IP1 to IP6 over here, just like this. I can hide the indicators like this. Just like this. And I can create here their second order constructs, which is bank performance. And I can put here the indicators in the same way as I have done previously, just like this. So what I need to do here, I need to connect these two just like this, and then I need to connect this with this. So it is completed. Always remember, you need to include your covariance with your independent variable only.